Okay. So what does that mean? Let's draw a picture. Remember, we draw poles and zeros in the Cartesian axis where the real part is the x-axis and the imaginary part is the y-axis. So if you have poles, for example, we have, let's say, GZ of S equals and I want to get used to this representation instead of factoring them out. How does that factor out? If I give you S plus A squared plus B squared, how does that factor out? From here follows that S plus A equals, well, S plus A squared equals minus B squared, from which follows that S plus A is equal plus or minus square root of minus B squared, right? Which means what? Okay? In other words, S equals minus A plus or minus IB. It's the factorization of S plus A minus IB times S plus A plus IB. You multiply them through, you get S plus A squared plus B squared. Okay? So when you see S plus 0.1 squared plus 7 squared, what is the location of the poles? What are the poles?
-2.
-2, and I have a pair at minus 0.1 plus or minus 7. Okay? So I will draw it in the picture. Minus 0.1 plus or minus, it would be, here's the complex quantity pair, and the other pole would be minus 2. Okay? This would be the location of the 3 poles. That's.
Wait, can you do that then? Which are, can you say which poles are which?
Okay. This is the real part. So these two have real part minus 0.1. So here is minus 0.1. And they have imaginary part plus or minus 7. So here is plus 7, here is minus 7. So this is minus 0.1 plus 7i, minus 0.1 minus 7i, and this is minus 2. Okay? So this complex conjugate pair is the rightmost. So in this case, the condition is definitely satisfied. But suppose that instead of having 0.1, I had here plus 10 squared. Then, instead of being this picture, there would have been minus 10 would be the real part. If I have plus 10 squared here, would be minus 10 plus or minus 7. Bring. Felix.
And what's -2? Why -2 is not the real part?
Why minus 2 is what?
It's not the real part.
No, that's a different pole. That's a different root.
It's not imaginary. It has no imaginary part.
This is the same as
So it doesn't play
that on top you reduce it, it's 7 plus 2. You know, 7 plus 2 would cancel out, and would affect
What do you say 7 plus 2?
you have 7, you have S,
Oh!
S squared.
Did I put a cancellation here? Hold it. That's, oh yes. I shouldn't have had the cancellation. Okay. Let's change this top to, yeah, you could have canceled that so you wouldn't have to draw the minus 3. You're right. And I'll discuss that. But good point, Robert. Very good point. Yeah, but Robert very astutely noticed that the numerator I had given you would have canceled the s plus 2. So let me give you a different numerator. Let me give you s plus 3, s plus 1. So that would be 4s plus 3. Right? Let's see now. S plus 3, s plus 1. Yeah, perfect. So let's change that like that so that it's fun to cancel out. Yeah. You could have been right. In that case, it would have canceled out. It would have been different. So, you understand, Felix? These are the 3 poles that I have. Minus 2, minus 10, minus 7, 9, minus 10 plus 7, 9. So in this case, they would be at minus 10 here, and plus or minus 7, 9. So here is the minus 10 plus 7, 9, and here is the minus 10 minus 7. So in this case, the dominant is which one? The minus 2. In this case, the condition would have been violated. Why?
The farthest to the right.
The farthest to the right is the dominant. Whichever is to the farthest to the right. So the rightmost one here is the minus 2. That's the dominant. Before, when I had this at point 1, there was the dominant one.
Since the real part was the rightmost, that means they will be observable.
Say again?
Since the real part was the rightmost and closest to the origin, it would be.
Well, no, if it was positive, it would still be the dominant. But then my system would be unstable, right?
So what constitutes close to the dominant pole?
That's an excellent question. Basically, do the comparison e to the minus this guy versus e to the minus this guy. If this term is much smaller than this term, which leads me to what I was going to show you next, the wire. So we know that, so we have this situation, and z prime bar for a step change is going to be what? Will be the change in z over s. Okay? If z changes by delta z, okay? If z changes by delta z, okay, then z prime bar changes from 0 to delta z. So z prime bar would be delta z over s. So for a step change, the Laplace transform of the input is the magnitude of the step change over s. Clear? Dylan? Okay.
Just the last part.
Yeah, yeah. I look at your face, that's why I asked. Okay. Say the input changed by delta z. And that changes from its nominal value, changed by delta z. So the new value of the input is z naught plus delta z. Okay, so the actual input changes from z naught to z naught plus delta z. The deviation, which is actual minus nominal value, changes from 0 to delta z. So since the deviation is constant, for the positive times we're interested in, what's the Laplace transform of a constant? Constant over s. So it's delta z over s. So my y, so GQ of s, and let's, for simplicity, assume that the poles are all single multiplicity 1. So GZ of S will be something over S minus pole 1, S minus pole 2, S minus last pole. So that's the GZ of S, and Z prime value is delta Z over S. Careful, S is not a pole. Okay? S is not a pole. Poles are only the denominator roots of GZ, not the denominator roots of Y prime value. So, using partial fractions expansion, we're going to get something over S minus P1 plus something over S minus P2 plus something over S minus Pn plus something over S from that. Which means, with a delay, delay just simply pushes things to the right. Just to keep the picture simple, let's not put the delay here. I just want you to understand the concept. So, Y prime of t, neglecting delay, which shifts things to the right. Y prime of t will be something e to the p1t plus something e to the p2t and so on plus something e to the pnt, and from here will be plus something. Do you understand conceptually? I don't care what the constants are, I'll have some constants, but that's what I'm going to have. And if I have even one real part P positive, this thing blows up, okay? That's how we get the stability. Okay? Yeah.
In the example that I looked at, the oscillation won't be observable because the conjugate pair is not dominant.
Okay. Can you stay with me here? So, in the example I have up there, I have up here, I will get Y prime of t equals something, what's my first pole? Minus 2. E to the minus 2t. And then I have the complex conjugate pair plus something e to the minus 10 plus 7it plus something e to the minus 10 minus 7i t plus something for the constant of S. That would be what it would look like for the example I put up. Okay? Now, here's a fact. Complex conjugate pole pairs will have also complex conjugate C's in front of them. And you can do algebra to overshow that this will combine into e to the minus real part, cosine or sine the imaginary part. So these two will combine to something e to the minus 10t sine 7t plus something e to the minus 10t cosine 7. So the complex conjugate pair will always give us the real part will become a pre-exponential factor, and the imaginary part is the frequency of oscillation, sine or cosine. So let me ask you something. Yes,
What happened to the top part?
what do you mean?
Are you ignoring the top part or what?
What are you talking about?
S squared plus 4s plus 3?
If it doesn't matter what the zeros are, these affect the constants. And the constants are, the zeros affect the constants.
Okay.
Okay. So, think now what happens as time elapses? At time 0, each one of those e to the minus something t is 1. But very soon, let's say after let's say the units are seconds. After 1 second, what is this term? It's going to be e to the minus 2. Someone can grab a calculator quickly and calculate e to the minus 2?
0.135.
So this, after 1 second, this guy becomes 0.135. The pre-exponential, which is what? That's the amplitude of the oscillation. What is e to the minus 10? So 4 times 10 to the minus 5. After 1 second, what happened to the amplitude of the oscillations? Totally disappeared. Are you going to see that? If what you're looking is magnitude 0.135, are you going to see something that is 0.0004? That's fourth significant figure. And it goes down very fast. You understand what happens? So there are mathematical oscillations there, but their amplitude, relative time, drops immediately to 0. So your answer about close. Well, clearly in this case, it's fine. Now if you had minus 2 and minus 2.5, probably if you're saying something like 10%, probably you would be saying, think you're saying typically 2 significant figures, so you would have to judge if you're going to be saying it or not.
I think last class you said if there's a conjugate pair, you would have like oscillations. So when do we?
Mathematical oscillations.
Yeah. So when do we?
Yeah, that's the first part. But they're not observable. But we're not going to see. There are oscillations. These terms are oscillations. But they're oscillations that we don't see.
Oh. So when do we see them?
Because their amplitude disappears
No.
immediately.
No. When like in what?
When it's what I said at the beginning. If you have something that is, I don't remember what numbers I put. I put something like 5 e to the minus t, and then I put something like 0.001 sine something. What is that?
You'll see those.
E to the minus 70. And this is negligible in comparison to this. You wouldn't be saying. Okay? Remember, sine and cosine is bounded between minus 1 and 1. So what you are saying, sine and cosine, is always between minus and 1. So this completely specifies the magnitude times the exponential factor. Specifies the magnitude of what you are seeing. So the frequency doesn't specify the magnitude of what you're seeing. So sine and cosine is always bounded between minus 1 and plus 1. So the sum of the signal, what you would be saying in the plot, is the amplitude is the upper bound, right? And if that is disappearing very fast in comparison to the slowest term that disappears, and which is the last term that disappears? The dominant one. Okay? All others die faster. The more to the left you are, the faster you die. So that's why the rightmost is the dominant. Felix, okay? Yes. Dylan. All right. David? Who's back there? Mika? All right. So that's the first condition. The second condition is actually easier to check analytically. The second condition is